In this lecture set, we'll be moving beyond our discussion of dealing with data and begin discussing how we can analyze data using SPSS. While some of the data tools that we've discussed in SPSS have been powerful, really the reason people use SPSS is for its analytic capabilities. And we're going to start out today by discussing some common descriptive statistics that folks can run and use within SPSS. Now, there's going to be broadly two types of statistics we talk about, and that is statistics that we do with nominal variables and statistics that we do with scale variables using SPSS's terms, or said another way, statistics that use categorical data and statistics that use continuous data. We'll start by going to Analyze and then Descriptive Statistics to access many of the descriptive statistics we'll talk about in this particular video. Two options that we're going to be discussing are frequencies and descriptives. We use frequencies typically when we're talking about nominal data, and sometimes with continuous or approaching continuous data depending on the circumstance. And you can check out some previous videos where we investigated age using frequency to identify some weird things that were going on with an uncleaned age in the RSE dataset. You can also use descriptives, but descriptives typically are used for continuous data. And ultimately, what frequencies do is calculate how many individuals have every given number in a particular variable, while descriptives calculate things like the mean and standard deviation of that variable. How many individuals have each of a given response within a variable makes a lot of sense for categorical variables, and means and standard deviations makes a lot of sense for continuous variables. So this isn't just an artificially made up thing. This is, we use frequencies when it makes the most sense to do so, and we use descriptives when it makes the most sense to do so. Frequencies, again, typically for categorical data, descriptives for typically continuous data. We'll start with frequencies, and I'm going to scroll down and right-click to access my variable names. And I'll be doing frequencies of gender and source. Gender is a binary variable with male, female, and other, and also missing options. And source is a listing of where the participant came from. Now, in a previous video, we may have discussed this briefly within the context of reading in data and investigating that. Now we're shifting the conversation to really looking at investigating our data for analytic purposes. And because of this, we're going to go a little bit more in depth. Investigating statistics, you can see that there's a ton of different values that I can investigate. I can calculate some percentiles. So let's say I wanted the first and second quartile, say for the interquartile range or something like that. I could calculate that via this. There's a bunch of different other variables I could do in case I was using, say, an ordinal variable and a mean or a median made sense. I can look at skewness and kurtosis within here. I can calculate some different charts with my data. So if I wanted a bar chart, a pie chart might be interesting. I'll use a pie chart. And do I want the pie chart to be filled in with frequencies or percentages? I'll select percentages just for fun. I think that tends to make the most sense with pie charts. There are some different format options. I'll be quite honest, I don't play with this too much, except maybe suppress tables with many categories. So that is if I had a whole bunch of different categories, say I was using country, where there's, 30 or 40 different countries listed. Maybe I want to suppress the ones where there's only a certain number of entries. So like I don't want to look at any countries who had less than 5 people say that country within this data set or something like that. But I'm not going to worry about that here. Style and Bootstrap are some fancy options that you can do as well as create APA tables, and I'll skim over those and instead go on and click OK to look at my basic output. And again, within this lecture set, now we're going to begin exploring the output of SPSS in a little bit more detail. So here I can see I have valid and missing. I have some interesting things here. Choose from a drop-down list. This was the label that I gave to the variable gender, I believe. And I can change that up if I want to. In fact, let's go on and discuss how we can change tables in SPSS right now. you see if I hover over a table, a little option or notification appears that I can double click to activate the table. So if I hover over a table, I can double click to activate it. And this gives me some interesting options for that particular table within SPSS. Now, though this class is an SPSS course, this is introductory and at a pretty basic level. So we're not going to discuss all of the possible things that you can do within here. But allowing SPSS to use labels that make a lot more sense is something that's very useful. And so I do want to make sure we take a little time to discuss how you can do this for your own research, whether you're replicating someone else's paper or implementing this for a study that you have designed. Going to the View button, you can see that about 2/3 of the way down is something called Variable Labels. And by default, Label is checked. I can go into this and instead select Name, which is, instead of displaying the variable label for each of these variables, going to display the variable name. That is what I see on my data set. And that might be a lot more interpretable, at least for my instance and how I've labeled these variables, than including the variable label that I've included. All I have to do is X out of this, and you can see now that table has been changed. And for me, maybe that's a little bit more interpretable. That for gender, I had 35,973 valid observations with 145 missing observations. And for source, I had 36,118 with 0 missing. And you'll notice the 0 missing because within source, there was no missing values. There was no missing label for source. In a data set where there are missing values, this tells me that this was likely computer generated. That's not always true, but that's just my experience speaking through here, that if everything else has some missing values, a variable that doesn't is either has kind of a catch-all for missing values or maybe was generated by the client or whoever gave me this data set. All right, scrolling down. What can we interpret here? Well, we have male, female, and other. So this is our gender. And again, you see choose from a drop-down list is the label here. I can see if I can double-click into this and again use the name instead of the label. I can also click in and edit this to make it a little bit nicer, capitalizing gender. And so that way when I see this table, and now it's gone all gray. I apologize about that. That way when I see this table, it looks much more professional. There, just glitching out for a moment. All right, so looking in my sample, I can look at the frequencies of each of these, but to be honest, saying I have 14,000 males, that doesn't always mean much to me. Typically what can mean a little bit more is the percentage. I had about 40% male, I had about 59% female, and about 1% who marked other, making up my total, and then about 0.5% of my data was missing for this particular variable. About 99.5% was not missing. So this can be very useful. Notice that SPSS for these frequency tables has a valid percent column. So you'll notice in the percent column that the total percent of male, female, other, our 3 response options, is not 100%. And that means that each of these percentages add up to 99.6, and that's because missing was included as part of the percent. The valid percent says what percent of the valid non-missing respondents responded male. And you can see that because we only had a small amount of missing, the valid percents are only slightly different than the percentages. But if we had a large amount of missing, these valid percents may make a lot more sense, where I would say 39.9% of the respondents on this question were male, even though 39.8% of all participants were male. And again, the difference between that is of the people who responded to this question and of the total number of people who I quote unquote included in my data set, even those who didn't respond to this question. So a couple of different interpretations here, and sometimes both of these can be nice. Typically, I would report the valid percent, being careful to note this is the percentages of the respondents to that question. And that's because if I read that, I don't know, let's say we had a large amount of missing, say 30%, and you reported 30% of the sample was male, 40% of the sample was female, and I kind of did a little bit of, and 1% of the sample was other, and I did a little bit of mental math and said, hey, that adds up to 71%. Where's the other 30%? The answer is in missing. So it may make more sense to say, of the participants who responded, this is what they said. So I personally tend to use the valid percent, but I'm always careful to note that that's what I'm doing so that nobody gets confused. All right, how the user came to the page. So one thing I'm looking for here, this is a bit of data cleaning, but I remember 0 missing up here. I want to see, did all of my options fall within the coded responses? Now, if an option didn't fall within the coded responses, what you're going to see is that here in the options of where they respond, you'd see like a number that doesn't have a label to it. And that would be a good indication that I didn't label some of the responses or that something is outside of what was indicated in my codebook. And that would be something to go back and check. Here, though, I can see there are no missing values, no unlabeled values. It really just was these 3 options: front page of the website, the Google search, or other. Looking through these, I can see that the majority of my participants came from the front page of the website. About 6.5% came from the Google search, and again, about 25% came from other. Again, I tend to interpret using percentages because I know these add up to 100. Saying about 9,000 participants came from other, that sounds like a lot, and it kind of is, but again, it's within the context of how many total participants we had, and at the end of the day, even if you gave me both numbers, I'd probably do some mental math to try to get to this percentage number to interpret. So I tend to start with the percentages, though often you'll have to report both the frequencies and the percentages at some level, or some publications like you to report the total sample size as well as the percentages, or the total sample size with the frequencies with percentages and parentheses, or everybody has their own format for this, and so be careful about that. Here, again, you can see that the label is being used, but how the user came to the page, this is actually, to me, a much more descriptive label than just the word source. So I want to keep that in there because I think that's a lot better of a title, even though the gender one was a lot worse of a title. It just depends on how your label and how your variable names are created. Again, we have valid percent, but you'll note because there's no missing values, the percent and the valid percent are identical from one another. So there's no distinguishing these 2 columns from one another. Scrolling down to the pie chart I made, and I actually have 2, one for each of the variables. This is the male, female, and other values listed in here. And then I have, for the source, the front page, the other, and the Google search. I found it really interesting that Google search is such a small slice of this pie and other is so big. Normally other categories tend to be a relatively small percentage, but here if we go back up to our table, we can see other was 25%. So I guess that does make sense. All right, well, these are tables I could copy and paste into a report. I might do a little bit of extra formatting or add some numbers to them if I wanted to. Up here, I have some percentages that I can access, and different percent, valid percent, as well as the frequencies of different categories, and some statistics, broadly speaking, on for all of my variables, what was missing and not, as well as how we can change some titles and some column labels to make them more or less interpretable depending on what the label is and what the variable name is. All right, so this has been frequencies, how we look at categorical data. Let's talk about how we look at continuous data. And in this data example, we really only have one continuous variable, that's age. So I'm going to go down to descriptives and right-click and use variable names again, and then go to age and move that over. Now there's different options available in descriptives, some of which are the same as the frequencies. The big thing within the frequencies is those frequency tables. And again, that makes a lot of sense within categorical data. The big thing within descriptives is things like the mean, standard deviation, minimum, and maximum, which actually you saw some of these available within the frequencies as well, though it would by default give us the frequency tables as well, which is not something we're particularly interested in. For descriptives, mean, standard deviation, min, and max are the default options, but you can see there's a variety of different options that you can select within this, as well as the style and bootstrapping features which you can play around with. I'll click into these menus. These are not things that we'll use within this class, but just so that you can see what they look like briefly. Last but not least, within our data cleaning lecture set, we discussed how we can standardize variables by subtracting the mean and dividing by the standard deviation. But here's a cool feature for when you're doing this in a hurry. When you use the Descriptives menu, it has a checkbox that says Save Standardized Values as Variables. And ultimately, what this does is not only does it give you the output that we selected within Options, but it saves another column within your data set with whatever variables are listed in the menu standardized so that you don't have to go through that process by hand. This is a great shortcut. Again, if you're looking to standardize maybe multiple variables, this would be a fantastic option. If I had to standardize 10 or 20 or 30 or 100 variables and I didn't want to go through the process of going to transform, compute variable, calculating the mean, calculating the standard deviation, writing out the equation for each and every one of them. That sounds like a pain. Here, I could simply move all of the variables over into the menu, click Save Standardized Values as Variables, and then select OK to run. Here, I'm going to skip that step. I'm not particularly interested in our standardized age, and I'll just select OK. What you'll note quickly is that within my output document, I have saved or continued to save in the output. So the previous frequency information is still here. Now, this can be great sometimes. For instance, if I want to build a useful report, but sometimes this can be a little bit of a pain. So it's important to realize that one way to refresh the output is to close it, choose not to save, and then I can rerun the analysis and it gets its own output document. Another thing that can be handy is you can select features on the left-hand side and simply I'll click on the symbol next to it, and if I right-click, I can actually look at some different options that I have to cut or copy these things. I can also simply press the delete key to delete that whole feature. So for instance here, I deleted all of the pie charts if, say, that wasn't something I wanted to include within a report, if I'm running this for myself and wanted to save my output as output of analyses that I wanted to come back to later, or if I were trying to send this output to, say, a dissertation committee chair or something like that, and wanted to make sure they didn't get confused that I wasn't wanting them to look at the descriptives table. I really wanted them to just look at this table and that table. So I could go in and delete these other tables that I'm not particularly interested in. So let's say I didn't want this initial statistics. This wasn't something I asked for. So I could select the table, select the delete button, and that would be removed from my output so that I can only save what I'm interested in. It's a very, very handy feature. In any case, that's a bit of an aside. What we were exploring was age as a variable. Now down here within age, I can see the minimum's 18, the maximum is 99. This is because I'm using my cleaned data set. It's been cleaned so that anybody outside of 99 was removed. I have my mean age is 30.07 and my standard deviation is 12.245. This is very, very interesting that my mean and standard deviation are this. The mean, because the mean is much closer to the minimum than the maximum, indicating that my population of respondents or my sample of respondents actually has a much lower mean age than maybe would be expected by the mid-range. And my standard deviation looks to be about 10 years. So within about 20 years on either side, or 25 years on either side of my means, where I'd expect most of my respondents to fall. This doesn't make much sense on the low side, but might make sense on the high side. Of course, the other thing is that this distribution definitely might be skewed, and that's something that I can explore when we start playing around with graphics. All right, well, let's continue exploring our descriptive statistics options. One other option that we have is crosstabs. Now, crosstabs is a way to tabulate information. Let's go back to our categorical variables, gender and the source, how you came to the web page. Crosstabs is a way that I can have my rows be one variable and my columns be the other variable, and then the entries in the table is how many people fall within each of these. Sometimes these are called contingency tables. In certain specific situations, it can be called a confusion matrix. But SPSS calls these types of tables crosstabs. So let's look at making them and a couple of different options we have. Opening up my crosstabs menu, I can see that there's row and columns that I'll have to enter. And I'm going to typically do this for categorical data only. So I'm going to use my rows as gender and my columns as source. And what I'll expect is male, female, and other to be my gender rows. And my source is going to be the website, Google, and other going across. Now, there are many, many, many different things that I can play with here. Let's explore a couple of them. There's a bunch of statistics that we can calculate based on these crosstabs. Some of these look at the relationship between the variables and do statistical tests for that. One common statistical test is the chi-squared test, which assesses are the rows and columns independent of one another. Sometimes you'll hear that called the test of independence, the chi-squared test of independence. The other thing that I can say is, what do I want to be included in the cells? So as we discussed earlier, for where male meets the source, let's say Google, that in the cell, what do I want to put there? Currently, I'm going to put the observed frequencies. That is, how many total people were male and came from the Google source. But there's some other different options I could do. I could do percentages calculated per row, per column, or total, and each of these have different usages and different times where I'd prefer this. I could do residuals. I could do expected counts. Again, a variety of different options. I'm going to leave this as observed so that I can just see how many individuals fell within that. Format is a pretty mild menu for this one, just asking how do I want this to be, ascending or descending. Remember, gender is coded 1, 2, 3, 4, 5, 1, 2, 3. Source is coded 1, 2, 3. So I'll leave this as ascending. And again, style, bootstrap options we're not going to play with in this class. Just for fun, I'll also choose the display clustered bar charts to demonstrate a bit of what a clustered bar chart is. And again, there's so much more we can explore here. We just won't have the time, unfortunately, within this level of class. Now, I don't know if y'all are noticing, but I'm starting to get a little bit confused as to where my tables start and where my tables end. One thing that you can do to help keep your analyses distinct, especially when you're saving it all within the same output file, is to double-click a heading and to change the size of the heading. By default here, SPSS has this as 10.5. I'm just going to make it the biggest heading possible, which is 27, it looks like. Yeah, it looks like that's as big as it's going to let me go. And this way, as I'm scrolling down, I can quickly see, oh, this was where I ran my frequencies. For descriptives, I'm going to do the same thing. Double-click the title, highlight it, and then click the size up arrow until I get to a much bigger size. So there's my frequencies output. Here's my descriptives output. And here I will have my crosstabs output. And that'll help me navigate a long output file much quicker. And again, thinking of your dissertation committee, dissertation chairs, any statistical consultants you ever work with, or just you currently thinking of future you and wanting to be really nice to future you. If you ever come back to an output file that you save, say with the results of an analysis you ran, it's going to be really nice to be able to navigate that file easily. It's also going to be really nice to have all of your results nicely placed in one spot so that you don't have to go hunt all over the place to try to find these results. I just have the relevant frequency output, the relevant descriptives output, and the relevant crosstabs output. All right, looking through this, I can see for the case processing, this is just indicating how many valid observations I have, and this is for both the gender and the source. Now again, I'm looking at this and this is getting a little bit confusing to me with chosen from a drop-down list. I'm going to double click and edit this. And instead of editing the whole table, I'm just going to edit the particular thing because I actually quite like how the user came to the page. I think that makes a lot more sense than source, but chosen from a drop-down list doesn't make much sense to me. So I'm just going to change that to be gender manually by double clicking into the section I want to edit and typing the word that I want to see, and then I'll X out of it. And I don't get that glitch this time, which is kind of handy. All right, so looking here, I can see 9,818 males came from the front page of the website, and 14,482 females came from the front page of the website. 255 individuals who marked other for their gender came from the front page of the website. And then within a Google search, I have 779 males who came from a Google search, 1,521 females who came from a Google search, and 15 individuals who marked other who came from a Google search. And then I have 3,760 males who came from another source, 5,310 females who came from another source, and 33 individuals who marked other who came from another source. Now, what's cool about these crosstabs is I still can see the total counts for male, 14,357 males, 21,313 females, and 303 individuals who marked other, as well as the total counts of the individuals who came from each source. 24,555 individuals came from the front page, 2,315 came from Google, and 9,103 came from other. I should note that these will, I don't want to say always line up, because if there's a value missing from one of these variables, that value is going to, in this particular setup of the table, be removed. So you're not going to have that information. And so you may have a little bit more missing values here. This is going to include all of the values here who are present for both variables. So the presence of missing might make this total column be a little bit different than if I just ran gender by itself when I did that earlier. In this particular case, that's not going to be the case for gender. So I'll see that if I scrolled up gender, 14,357 for males, 14,357 for males. So that's going to be just fine for gender. On the other hand, when I calculated my valid numbers for the source, I had no missing data, but now in this table, I do have some missing data. So while previously I had 24,653 individuals who came from the front page, now I only have 24,555 individuals who came from the front page. And that's because the individuals who are now missing from this sum are individuals who did not list their gender. So missing this in one variable impacts the count in the other variable, and that's something to be careful of. Here, my chi-squared test, and again, this is a test of independence. Not something we'll talk about in this. This class is just how we can run things, and we'll have a whole other video on running statistical tests. So I'm not going to dive into this, but I can see that there is a statistically significant difference, or these two variables are statistically significantly related. So it does appear that your gender and what source you come from have some level of relationship, and we could, of course, investigate that further. Down here within my bar chart, I can see the distribution of the source for males, females, and other. I can see that the bars are typically larger for female, and actually that doesn't indicate a difference. That just indicates that there's more females than males. I can also see that, of course, Google search is lower than the front page, and other is higher than the front page, and these patterns tend to hold across male and female. Now our test up here actually says that the pattern is different between male and female and other. But down here within our data, we can see that the pattern is broadly similar among these. We just have more females than males within this particular chart. All right. Well, let's talk about how we can calculate correlations between variables, and maybe that'll be a good spot to end our discussion today. Oftentimes, calculating correlations between continuous variables, or in our case, we're going to calculate correlations between items, which are listed as ordinal, can be very useful when determining natures of relationships between items. To calculate correlations, we're going to skip beyond descriptive statistics and go straight down to correlate. And I'm just going to do the bivariate bivariate, and I'm not going to click the with confidence intervals. You certainly can if you want confidence intervals. But I'm just going to look for correlations among my 10 items. Now here I'm going to hit reset so that everything's nice and clean. For your view, I'm going to right click and click display variable names so that I can more clearly see the names that I'm looking for, and I want to select Q1 through Q10. Selecting the top option and holding the shift button and then clicking the bottom option I'm interested in selects all items between the top and bottom, and then I'll just click and drag them over to be the variables that I'm interested in. Now there's a bunch of different options. I have some different correlation coefficients I can select. I have some different tests of significance I can select. I'm going to flag significant correlations. It'll put little stars next to the significant ones. What's interesting about a correlation matrix is that the top right and the bottom left are exactly the same, so I can say only show one of those so that I don't get confused by looking at the top right or bottom left. I'm going to skip that for now. In options, we have a couple of different options that we can select for statistics, and I do want to see if there's an option in here. No, I don't see that in here, so we'll just go on and leave this here with our options and run our correlation. So within these correlations, you can see that each of the items are coded, and within each of the codings, actually, this is quite nice for me because I can see what I believe to be the reverse coded items. So I believe that every item with a star is going to have a negative relationship to every item without a star, and I can check this. The first question, I believe that I'm a person with worth at least on an equal plane with others, compared to the third question, all in all, I'm inclined to believe I'm a failure, has a negative relationship between those two. And again, that's a good indicator that that's a reverse coded item. Now, that's a really handy thing within my label, but my label also makes the table pretty big. So I might double click into my table, go to that view, variable labels, and include only the variable names instead of the full label to make my table a little bit smaller and easier to read. Here I can look at the relationships between all my items, investigate if there are any particularly strong relationships, say between question number 6 and question number 7 has a correlation of 0.792, or any particularly weak relationships. Here, the relationship between question number 8 and question number 2, question number 8 and question number 4 is a lower one. Not because it's negative. Negative just indicates the direction of the relationship, but because of the magnitude, 0.297 is not a particularly strong correlation. And this is how we create correlation tables, and we can go through and interpret these results depending on what our context is. You'll note that SPSS by default provides your correlation coefficients. The stars indicate statistically significant correlations. You're provided with a two-tailed p-value as well as the sample size for each. Now, it's important to realize, and you may not have thought about this before, but in such a table, the sample size is not going to be consistent for each because, say, for the correlation between question 1 and question 6, I need respondents who have answered both questions. And there might be a different number of respondents who answered both question 1 and question 6 than respondents who answered both question 1 and question 7. And I need respondents, again, who've responded to both questions. So each cell within this correlation matrix is potentially going to have a different sample size. Along the diagonal, I can investigate how many individuals responded to each of the questions. So, for instance, this first diagonal, question 1, I can see 36,049 participants responded to the first question. I have 35,870 participants who've responded to the second question, etc. So I can explore that, but it is important to realize, and again, something that's not often considered within such correlation matrices is that each particular entry in a correlation matrix can have its own sample size. And in fact, in the presence of missing data, certainly missing data that each question potentially has distinct missing data, if that's the case, each cell will have its own sample size that's completely independent of the other sample sizes around it. And I say independent, but completely different than the sample sizes around it. So you have to be careful when reporting correlation matrices. And again, SPSS does a nice job of displaying this, even though it feels like a little much. And it certainly does to me too. But the reason they do that, again, is because each one of these does have a different sample size. And so if you're reporting sample size, I can't just report, hey, I had a total of 35,973 participants who answered my male, female, other question. That is not the appropriate sample size for a correlation matrix because, again, each cell has a different sample size. In any case, in this video, we've discussed how we can analyze some basic descriptive statistics, including frequencies for categorical variables, descriptive statistics for scale variables, and use crosstabs for pairs of categorical variables. We've also talked about how we can create correlation matrices with a few options and how we can edit some tables within SPSS in order to make them a little bit more readable. Finally, we discussed how we can edit some of the SPSS output, including deleting pieces of output, as well as changing some header information so that we can more clearly and easily find information within SPSS output.